All right. This is recording. Oh yeah, it's chapter 5. Actually, no. All right. Okay. Let me just share my screen for the people at home, which is nobody for now, but perhaps a few people later. Okay, sorry for the delay. It's just setting the cast now takes an incredible amount of time. Anyways, so we were here last time. So why do we need to apply the equimarginal principle to abatement cost? Well, because we want to do as little work as we can, if we can, because that means that we can do a lot more. So if I go to the government and I say, please give me 10 million to abate 10 tons, then yeah, that sounds okay. But if I say, please give me 1 million to abate 10,000 tons, then that's much better and much more likely to be accepted. And this is what economists would like. Economists, we care about making things efficient so we can accomplish the most with the least effort. All right. So how do we do that? Well, the thing is, we have to equate the marginal cost of abating emissions to the marginal benefit of abating emissions. So this means that we have to know what is the minimum possible abatement cost for every possible level of abatement. And this is why we need to aggregate the marginal abatement costs. And the thing is, this works exactly as we would for a normal demand curve or supply curve. So we just have to express everything in terms of quantities, then we add things up together, and then we can express it back in terms of inverse. Or here it would be just marginal abatement cost curves, basically. So yeah, here. So before showing you this, I'm going to show this. Oh, I don't have my notes. All right. Okay, so here we were last time. So let me explain to you again what we're doing. So what we're asking here is, what if we thought that paying $30 per ton to abate was a good idea? How much in total would we be able to abate? So we see that if we don't ask anybody to abate anything, so we have two firms, by the way. So So this is firm one's marginal abatement cost. It's 60 minus 4e. So here's the function. And I know that firm one, I already computed it. So if firm one doesn't, I don't ask firm one to abate anything, then firm one's going to abate to emit 15. That's the maximal emission. So so firm one is going to choose the level E such that MAC1 equals to 0. So I get that E will be equal to 15. I can do that for firm 2. And then I know that, so if I'm not asking anything to firm 1 or firm 2, then since these are the only two firms that emit pollutants in my world or in my economy or in my region, then what is the total emission that I'm going to get? I'm going to get 15 plus 15 equals 60. All right. And question? Yeah. Okay, not really. What did I do wrong here? Wow. Did I change a formula somewhere? I think I did use the same. So 60 minus 4e, 30 minus 2e. Here I'm, yeah, 60 minus 30 minus 2e. And here is, yeah, so, okay. Well, that's a surprise. Let's do that by hand then. Okay, so, well, please compute how much, well, it should be 30 then. Just to confirm. So, all right. Well, oops, I didn't think I would be doing this. Here we go. Thanks for pointing that out. That's a bummer. So 0 equals 60 minus 40. Yeah, I think it's just I should have written 30 there, but just to be sure, I'm going to compute it again. So I get that. So 4 equals 60. So E equals 60 divided. Oh yeah, that's 60 divided by 4. So that's 30 divided by 2. So that's 50. Right, so that's for this one. So 15 is good. Second one, I've got 30 minus 2 equals 0. So under 0. Equals 30. So yeah, equals 50. So again, that's 50. Yeah, so it's just that I should have written 15 there. All right. Let me use my magic powers, masking stuff. Okay, and now I'm going to continue to wing it because now I'm not sure about any of my computations. So now let's ask ourselves if we wanted firms not to pay 0 marginal abatement costs, but let's look at $30 per ton. So here, how much would we have? So this is for 0 abatement cost. And now let's look at $30 per ton. So we can just do exactly the same, but with 30. We get, so 30 equals to 60 minus 4e. So I get e equals 30 divided by 4. So that's 15 divided by 2. So 7.5. So here I get 7.5. And now let's look at the second one. Should be 0, but just to be sure. So I set this to 30, equals 30 minus 2e, yeah, I find that e equals. So I indeed get that the sum total of emissions, if the emission cost is set to 30, is the first firm, which has higher cost, is not going to want to abate everything because it's too expensive. This is the price of abating these extra units is super high for firm 1. Firm 2 has a better, more modern technology, so it costs less. And if I set the marginal abatement cost of firm 2 to 30, then firm 2 is going to abate everything. So the sum total of emissions in the economy is going to be 15 divided by 2, or 30 divided by 4, or 7.5. Right. And then once firm 2 has abated, so you see what's going on there. Here we add this line to that line, we get this sum total line. But then once I set the marginal abatement cost even higher, so firm 2 is not going to start abating a negative amount. Although I'm not saying that's not possible in the following sense, that when you have things like emission market and you have tradable permits that can be traded between firms, in some instances, what you see happening is very interesting. It's some people say, okay, what's the price on the market for, say, 1 ton or 100 ton? So what I'm going to do is just go out there to some country that's within the market and look at some instances in which there are big emissions of CO2. So for instance, or it could be CO2 equivalents. So for instance, in some dumps, if you put a lot of organic and inorganic matter together, that creates a lot of methane, and that's like 6 times worse than CO2, although it doesn't last as long as we know, but still that's there. So if you see, my project is to do something that's going to capture this methane. And now I'm going to sell this. So I'm going to essentially buy the permits, I'm going to. Yeah, so I'm going to have a negative emission essentially. So it's like if I act as a firm, but rather than reducing my emissions, I start going in negative because of my new project. And this has market value that I can trade. And more to the point, if for imagine firm 1, if the marginal abatement cost was super high, but then there's this other project which costs very little to do and abates as many emissions as would firm 1 do, then it's actually more economically efficient to just deal with this dump so that emissions are reduced rather than forcing this other firm out there. So that's the neat thing with markets, as we're going to see at the end, that they really allow people to just discover the best way to reduce emission and give us the best shot possible at making it alive out of this global warming problem. Yeah. So this is the aside. Aside is it would be possible to have negative emissions if you interpret it that way. However, in this case, if I'm giving, if I'm giving you this function there, what you have to assume is once firm 2 has reached 0, then it's not going to have anything else to abate. Here it's just, you just have these 2 firms. So then this is 0, which means that now there is up to 7.5 and lower, there is a single firm that's continues to abate cost, to abate emissions, and that's firm 1. So you have essentially a kink here. You have different slope. Here you have the 2 firms that are abating. Here you have a single firm that's abating. And so the goal is going to be to know how to aggregate these things. So here's a high level of what we're going to do. So of course, so what you see here is we never add costs together. So we never say, for instance, at 7.5 we add this to this. We say for a certain dollar amount, how much in total emissions do we get? So what we have to do is invert these MAC curves and then add the quantities and then invert back. So it's exactly the same as you would do with say marginal willingness to pay, for instance, for private firms. Yeah, so here's what we're doing. So for every firm, so rather than having, so this was just remind myself. So having MAC of I as function of emission, I'm going to compute how much emission does firm I produce for a certain level of oh, that's, yeah, that shouldn't be E there. Yeah, that should be something like price. Anyways, it's not super important, but it's just I realized that you don't really need to write them as functions. At the exam, as long as you get the right answer, I don't care how you came up with it. So this is to help you, but I think it's more confusing than. Okay, so once you have inverted all the MAC curve, then you add them up together, and then you get this this total emission as function of MAC, and then you. Okay, I see what I did there. Okay, yeah, that's fine. So this is yeah, but still confusing. So I don't want to mess with it. And then you invert it back. But what's problematic is that for some emissions, then you have yeah, for some level of emissions, then you have only one firm that's inside it, and for some other you have two firms. So now let's see how we do that for this example there. So we start by yeah, we aggregate quantities horizontally. So between a cost of 30 and 60, only firm 1 is going to be abating because firm 2 is already at 0. Then between 0 and 30, the two firms are abating. So step 1 is I invert the functions. So yeah, since here the function is 60 minus 4e, so I just express e as function of MAC. Same with that one. So E1 of MAC is going to be 15 minus MAC divided by 4. I hope it's the right, yeah, I think it's the right equation. Now I'm doubting myself everywhere, but I think that was the only mistake there was. Yeah, it makes sense because it has to start at 15 and to decrease. So yeah, that's what we have, 15 minus MAC divided by 4. And 2, its emission is 15 minus MAC divided by 2. And you see that since so if okay, so interpretation of this. Firm 1 has higher abatement cost. So emissions must faster. Increase cost. What I'm saying here is that, so here I'm showing you this function there. So for this function there, you see that it is, I get 15 minus MAC divided by 2 for firm 2. So it means that if I increase the cost, then the emissions can reduce very, very quickly, rather than here, if I increase the cost, then the emissions reduce slowly. Oh yeah, right. So yeah, that's not reduce faster actually. So, maybe I shouldn't write this. It's not super helpful. I'm trying to think of a good interpretation for you, but I think it's more confusing than anything. And then what I'm doing is I'm adding up the two together. So this is for emission. Zero and 30. So the total ES function of MEC will be emissions of 1 plus emission of 2. So it's 15 minus MEC divided by 4 plus 15 minus MEC divided by 2. So I get 30 minus 3/4 MEC. Yeah, and then what I want to find is at which point do I get this kink there? So I know that the critical emission is 30. So what I have to do is look at what are the emissions of firm 1 at 30. And I get that these are 15 minus 30 divided by 4. So that's 15 divided by 2. And if you want to know, so that's here basically. So 7.5. So at 30, I'm at 7.5 for firm 1, and I know that I reach 0 for firm 2. Right? And now to find the maximum level of emissions if no abatement, so that's quite easy. We just did it. Oh yeah, so that's 30. That's not 60. And then we can reverse this. So rather than having E as function of MEC, then we re-express MEC as function of emissions. But then we know that. So that's good for 0 to 15/2. And that section is good for emissions between 15/2 and 30. Does that make sense? Yeah. Okay, so anyways, I'm going to give you, if you're confused, I'm going to give you exercises to do that yourself. If you do it this way, it works perfectly well. But what I advise you really much is to start by drawing stuff at the exam. Just on your paper, draw MEC1, look 60-15, then MEC2, 30-15. And then you can pretty much guess what's going to happen there. That way, you're not just blindly following a procedure without verifying that everything makes sense. So that way, you know, I wrote a 30 there, but it was super easy to see visually that 15 plus 15, 60 doesn't. What did I write there? 30. Yeah, it was not equal to 60. It was equal to 30. Nobody said anything. Yeah. All right. So so that's how you would express it. And how is that useful? Well, because then once you have this, then you're going to get a marginal damage curve that's going to go over this curve there. So for instance, if I have a marginal damage curve that looks like this, then I know that what would be probably the optimal level of abatement. Well, it's when the marginal damage equals the marginal abatement cost. So that's the whole lesson of this class, is when it costs as much to population or to whatever we deem is valuable. So if you think that preserving species is valuable, that's all part of the damage that you include in this curve there. And this has to be equal to the marginal cost of reducing emissions. And of course, the problem then is, so if we didn't do that, then we wouldn't be able to compute this point there, because we wouldn't know for sure. Because essentially we have to know that whatever the abatement is, all the firms are going to abate, or the cheapest are going to abate first. And then the trick is to know whether I should use this segment of the curve, or maybe if it's a very high cost, then I'm going to have essentially firm 2 having abated everything, and I'm going to cross the segment where just firm 1 is emitting there. So if I had something like this, for instance, then I would know that probably the marginal abatement cost would be maybe 45 somehow. That means that firm 2 has abated everything, because it has abated everything anywhere above 30. And yeah, and then at 45, I would be somehow like somewhere like here. So that would probably be something like 7.5 divided by 2, so 3.25. No, 3.25. All right, so that's the kind of stuff you're going to have to do at the exam. So everything is linear, but it can be a challenge to deal with these kinks there. So I advise that you practice a lot. Oh, by the way, I'm going to post other exercises to do to prepare for the exam. I'm also going to post last year's exam. Last year's exam didn't go too well, so I may change a bit how the type of questions I ask, but they're going to look somehow alike. What was special about last year's exam is I tried to make it more easy by having a constant marginal abatement cost. And in that case, you don't have to aggregate, because you can just say, oh, since it's constant, then I know that it has to be this value for firm 1, this value for firm 2. You can do it individually for each firm. So really the problem is when the marginal abatement cost is not constant. So if it's like this, for instance, that's the case where you need to aggregate, because you have to deal with many firms. All right. Okay. So socially efficient level of emissions. Well, that's the place where I said where marginal abatement cost equals marginal damage. Here I just said, like, if only firm 1 is there, no firm 2. Whoops, not assuming. So what is the optimal level of emissions for firm 1 here? Well, I set MAC of E equals marginal damage of E, and I get 10 and 20. So if you have ever found a market equilibrium with linear demand and linear supply curve, then you should be good in these cases. What's more problematic, as I said before, is when we do have kinks. So like this. In that case, you have the extra step of verifying whether you have to find the intersection with this curve, or this part of the curve, or that part of the curve. And we're going to see in the exercises how to do that. So yeah, for a particular pollutant being released at the particular place and time. So everything is specific to the problem you're dealing with, of course. So what we care about is that the marginal damage be equal to the marginal abatement cost. So here the function I'm using is 60 minus 4e, and the marginal damage is just 2e. So it looks like the slope is less than 1, but realize that here it's 20 and here it's 10, so the slope is 2. So I get that the optimal emission level is 10, and the marginal abatement cost for 10 is equal to, of course, the marginal damage, and it's equal to 20. Okay. Questions about this? No, all good. So stuff that I can ask you to compute. So this is I'm thinking, do you want the formulas at the exam, or do you not want them? Yeah, you want the formulas, yeah. Because I don't think it makes sense to just ask you to just learn by heart specific terms, because at some point they're easy to, once you know that, you know what you have to do. So yeah, I'm not saying I'm going to do it, but I'm going to try and make it easy for you to not get. I don't want you to spend like half a day just learning. Okay, if it's MAC, if it's MD, if it's blah 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 blah. So yeah, I'll try to make an exam that's yeah, that makes sense. Okay, yeah, so something though that you have to know is, if you have the marginal abatement cost, then what is the total abatement cost? Well, it's the integral of the marginal abatement cost from the abatement of 0 to abatement of emission E. And you have to know that the total damage is the integral from emission of 0 to emission of E. So it's, yeah, total damage is this triangle there. So it's the integral of the marginal damage until whatever level you choose. So here it would be until 10, for instance. And what is the marginal abatement cost? Then it would be, yeah, so could compute it. Have PAC of 10. So here you have to make sure that you don't compute from here to here, because we start abating from 15, right? So that's equal to 15 minus 10 times the height of the triangle, which is 20, divided by 2. So you get 5 times 10, so 50. And the total damage at emission of 10 is would be, yeah, the integral from 0 to 10. So 10 minus 0 multiplied by 20 divided by 2. So that's is that the same? No, it's not. It's 100. Okay, this please know that. I'm not going to tell you this at the exam. Please use your judgment. So total something is the integral of the marginal. So here, total abatement, you start by not abating and you add up all the marginal abatement costs up to that point. And the total damage is, you start by 0 damage and you add up together all the damages. But then what I may tell you is something like this. So the total social cost Yeah, still, total social cost. Should I ask you to learn that? Okay, I'm not committing to anything. Maybe I'm going to ask. I'm going to think about it. This is still, it's somehow intuitive definition. So the total social cost of this phenomenon, of the phenomenon of pollution, is what is the fact that I have to abate and the fact that I still have to suffer some damage. And so I can never have no social cost because there's this, if I abate more, it means that I have less damage, but more abatement. So I have to pay more. And if I abate less, then I have more damage. So this is a principle that you can never have a total social cost that's zero. You have to pay at some point. So yeah, the total damage is 100, as we just did. Total abatement cost is 50. And the total social cost is the sum of both things. So it's total damage plus total abatement cost. Yeah, no, I'm going to learn. You have to learn stuff in this class, so please learn that. So okay. So it's not too complicated as a concept anyways, I think. All right. So here we go. And of course, what we want is to minimize the total social cost. And how do we know that we're at the minimum? Well, if we chose, for instance, to be here, for instance, then what's wrong with here? Well, here the marginal abatement cost is lower than the marginal damage. So I would have this deadweight loss, which would come from the fact that I'm experiencing more damage from pollution than I would have to pay to reduce it. So it would make sense to reduce this extra pollution. And here the deadweight loss would be this triangle there. And you can imagine I have a similar thing happening on the other side. So here, for instance, if I was at 9, then at 9, you see that so I'm choosing to vote green to reduce pollution as much as possible. But then what happens? Well, it turns out that at this level, the pollution is still making some marginal damage, but it really costs a lot to my firm to implement all these pollution reducing equipment. So in both cases, you would have, so I could see, this would be deadweight loss from under reduction, under abatement. And similarly, I would have here over abatement. Of course, if you ever encounter somebody from Greenpeace, never tell them that. Never tell them, oh, here, I think you want to reduce it, pollution too much. They're not going to be happy about this. So that's why economists are usually not too popular, because we always emphasize the costs of doing things, the limits of our world and of our technological apparatus. And yes, we just say no, whenever you want the world to be perfect, it never going to, because at some point, yeah, things cost too much money. And reality just always comes back. Even if you say, I'm going to get elected and have this huge green program, good luck. In the end of the day, it's you're going to face the fact that, yeah, at some point, physical limits exist, and it's just very expensive to overly do stuff. All right, so some exercises about this. So I just give you two abatement costs. So two firms that abate have marginal abatement costs, and the marginal damage curve, which is 3E. So should we start with this? Yeah, since we're in this topic, so let's do that one. So what I'm going to do is just try and do that with you and not check the answers. So see if we can solve it together. Just wait a second. So maybe I'm going to again embarrass myself by making arithmetic errors, but that's the fun part of doing things live. Okay, so let me share that screen. Marginal abatement of firm 1 is this. Marginal abatement of firm 2 is this. Question number 1 is how much will each firm emit if they don't make any effort to curtail emissions? So do it, please. So if you know it, please, you can say I have it, but I'm just still going to count in my head like a few seconds to let the other do it. So if you already have it, you can start thinking about the other questions. So the second one is, I'm just going to read it. If a mandate forces firm one to abate to have a total abatement cost of 50, how much will firm one emit? So here the government says to firm one, I don't care about your marginal abatement cost, but I care that you spend exactly 50 on reduction. So how much would that make firm one reduce or emit? So is one good for most people? Yeah. Um, two. Question one. So does that depend? Yeah, it depends on these things. So okay, anybody? What are the answers? Yeah, go ahead. Okay, 20 and 5. Let's see how it is. So once again, what you do is you say, well, if I let firms do whatever they like, they just want to pay zero. They don't want to pay a negative amount. It's not like if we tell them you can abate however you like, they're going to start producing pollution more than they would otherwise. They just pay zero. So you set the MAC. Equals zero. It's 20. So you get E equals 20. And 10 minus E. So you get that. E, yeah, let's say that's E1. E1 of 0. I don't know how to write it, but would be equal to 10 divided by 2, so that's 5. And by the way, so a really dirty trick to do it super quickly is you just look at these numbers there, and you take 10 divided by 2. That tells you what the number is going to be, and you take 20 divided by 1. That tells you what the number is going to be. So you just you don't even have to any algebra. If you know it, you can just yeah. Because again, I'm being nice with you, and I'm always giving you some linear curves. All right, so that's one. Two is so I'm just throwing you more of a curveball. So it's you have to think a bit more about what's going on there. Somebody have a problem knowing what to do for question 2, or yeah, no. Oh, you look like a smart crowd, or it's just a subset of people that came that are smart students. I think it's easy. Last time some were struggling, so if you struggle, that's normal. If it's too easy, I'm going to ask more difficult questions. Otherwise, everybody is going to have 95 and somebody has the answer. Yeah. What is it? Oh, -30? Oh, gee. Okay, so maybe I'm completely off track. All right. I'm just going to give you still 5 minutes. I see that most people are look like they're done. Yeah, what do you have? Yeah. 10. Okay, so we have differing opinions there. So again, as I said before, good thing is to draw stuff. Just helps you see what's going on. Okay, so here we need 20, then 10. And, 20. Yeah, then this one is 10. So here, assume this is 20, and this is 20. So that's MAC1. All right. And the total emission, the total reduction. So I don't know what it's going to be, but I know that if firm one chooses E1, for instance, here, so this is going to be the total abatement cost. So what is it going to be? Well, it's going to be 20. So PAC 1 is going to be equal to 20 minus E minus E1, let's just say, times MAC divided by 2. So this is equal to and this is 20 divided 20 minus. So here we have a function of total abatement cost for firm 1 as function of emission of firm 1. So here all I did is, so the total abatement cost is this triangle there. So it's 20 minus the chosen level of emission times the marginal abatement cost at this level divided by 2 because it's a triangle. And now I just have to set this to what did I say, 50? So I all right, so 100 this, and now this is just squared. So it means that what I can do is take the square root on both sides. It's 10. So then I find that 1 is going to be equal to 20 minus 10. So 10, good job. Who got it? Just ask curious. Oh, only one. Well, so you see, it can be doing drawing the curve is super helpful. I wouldn't dare start solving a problem without doing that, because otherwise it's confusing. And of course, this is a sort of artificial question, because what government would say, oh, I force you to have a total abatement cost of 50. No one would say that, but yeah, just to work a bit your skills. So let's just do that one for firm 2 for fun. So it starts at 10. So that would be half of that one. And it finishes at 5. So that would be a quarter of that one. So that would proportion that's like this. Yeah, so it's very useful to just do this initially to have the, you know, that this the horizontal, the vertical axis is going to start at whatever number you have here, and then it gives you the horizontal axis to do that. So that's 10, and you see that from one emits less. Okay. Third question. All right. So find the aggregate marginal abatement cost curve. If you want me to go back to the slides, because yeah, it didn't give you a lot of info. So please write these down, these formulae. And then I'm going to go back to the slide where I explain how you do it. Right. So very quick. Yeah, so first for all the curves, you invert them. Then you add up the quantity of emission. You get the total quantity as function of whatever the marginal abatement cost is. And then you invert back. And then what you know, of course, is that the first section is going to be made of just the firm with the highest abatement cost. And the second section is going to be this disaggregated function with the 2 firms. If I had 3 firms, then you would have to check however many small segments you might want to check. And then, yeah, the trick is to compute what are the limits on all of these things. No, I'm thinking this was fine. It's just it's not super informative. You can raise your hand when you think you have the right answer, or ask questions if you're completely lost. Or just find partial information, like how much would be emitted in total. This kind of thing. I can try and draw it. Some people have answers. Not yet. Yeah, it's just wait. I've made the drawing, just I didn't put any number. Yeah. Um, I think I'm going to discuss more the in the coming weeks. But it is downward sloping because we always assume that it's easy to abate. If you start from not doing nothing, then it's easy to, but it doesn't have to be. Yeah. So show you. So yeah, these curves can look and have different shape. And here that one would be possible. So that one would be downward sloping initially and then upward sloping here. And what would that represent? Well, it could represent, for instance, if my lake is very polluted, and then I just decide, okay, let's just start cleaning it, and I build some big plant around it, and then I start doing it. So the initial investment is quite expensive, and then once I start doing it, then initially it becomes cheaper and cheaper to continue to abate. But then at some point, my lake is quite clean, and if I really want to extract the last molecule of pollution, it becomes very, very expensive. But yeah, you're right. It doesn't have to always be positively sloping, but at the exam, it's possible it's going to be, or maybe it's going to be constant. But yeah, mostly it's constant or upward sloping. Okay, so let us just fill in some values there. So what's the value here? I mean the value, this value there. Are you sure? Yeah, it's 20. Yeah, so this is what would be the highest possible abatement cost. It's, well, that firm has already abated everything, and it's just that firm that's struggling, and the highest cost they can pay to abate the last unit is 20. So yeah, 20 is there. What would be this number here? 25. So that is, if I ask nobody to abate anything, then that firm emits 20, that firm emits 5. So in total, they emit how much? They emit 25. I should put some stuff on my axes. That's 2. That's 1. And then what is this number there? I made stuff up to scale, so you should be able to guess it. 10, yeah. So what's important here at 10? Well, so at 20, there's only firm 1 that's at cost that high. And then, but then when I go down, and then at some point I hit firm 2 that has costs of 10. So here the kink is going to happen when firm 2 starts to abate as well, or rather starts to not abate. So yes, that's 10. And then what is this value here? 10. So how do you find it? Well, you ask yourself, when we reach 10, how much is firm 1 abating? So you, yeah, to find 10 there. MPC. 10. What is it? It's 20 minus C1. So 1, 20 minus 10. So that's 10. What is the equation of this segment? We're sort of over time, but yeah. Let's just ask this thing, and then we can continue and ask what is this thing. Nobody has it? On this section, firm 2 is emitting nothing. So there's only firm 1. So what is the equation of this segment? Well, it's the firm 1's marginal abatement cost. So the total abatement in the economy is just going to be going on at firm 1. So it's MEC1. So it's going to be equal to 20. And then the tricky part is going to be to find out what this is there. That's the fun part of it, that you have to invert stuff. Somebody did it? Yeah? Yes. I think I confused. Yeah, it's 50 divided by 3. So does that make sense? Well, that's what anyway, so we continue, which let's check. But this minus E did I understand correctly what you said? Yeah, I don't think that would, I think it's 2/3. But anyways, we check this next time. So I'll post like longer questions. I post last year's exams, and next week we just do exercises to prepare you for the midterm. Okay, thanks a lot. Have a nice weekend.
Are you finished?
Yeah.
Okay.